angle slide. All right. So what you say? So the first thing that we need to understand before we start here, somebody there. Right, yes. So what does this mean again? This means the summation as R goes from 1 to 3 of 2R. So all it simply means is that I am summing up as R goes from 1 to 2 to 3. I'll sum these things up. That's okay? That's all this means, right? So that'll be 2, 4, and 6, right? 2, 4, and 6. That's 12. All right, nice. So there are some rules I want you to remember. Right? So the first rule is if you sum R going from 1 to n of a constant, what are equal to? If you sum a constant n times, what's the answer? This is something. N by the constant. So it will be n key. That's okay? If you have 200 of this, it will be 200 pi. That's all right. Next, if I give you the summation R going from 1 to n of, let's say, k by R, what can I do with this k? Pull the k outside, right? So I can pull the k outside. That's okay? That's some small rules for you to remember. This is rule 1, rule 2, rule 3. What about if you have the summation of R going from 1 to n of two separate expressions? Can I work them separately? Can I separate them and work it like this? Can I work them separately? Yes. If it's plus or minus, I can do the same thing. Everybody okay with that? Right, now for the most important one, right? Let's say I gave you the summation of R going from 1 to n of 5R, right? What's the first term? First term is what? 5 by 1, right? Second term is what? 5 by 2. What is, and that's skipping out a few, right? What is the last term? Last one. N. So it'll be 5 to the n, right? What's the second to last term? 5 to the n minus 1. Everybody okay with that? So here's my question. What is k plus 1 term? So let's pretend somewhere in here we have k. K could be anything. K could be 9, 10, 11, 12, it don't matter. My question is, what is the term in between there? K plus 1 term. what would the k plus 1 term be? Right? Mark it over. What would the kth term be? 5 by k. Correct? So what would be the k plus 1 term? 5 multiplied by k plus 1. I cannot see, right? So you have 5 to the 1 first term, 5 to the 2. Somewhere down the line, you have 5 to the k. Next state, you have 5 to the k plus 1. And then down in the end, second to last term, n minus 1, last term, n. Right? So it's important we understand how to get any single term. All we're doing is what? Put in the value per hour. That's all. So if I ask, what is it k plus 1 term? All you're doing is put k plus 1 where you see r. Yeah? Let's try one more like that. All I want right? All I want to know is give me the k plus 1 term. I want the k plus 1 term in this. That's all I want. K plus 1 term. I don't want the first, second, or the last or anything. All I want somebody to tell me is what is the k plus 1 term here. Yeah?
That's like k plus 1 squared.
7 by
K plus 1 squared.
you okay with that? All we're doing is putting inside here k plus 1. Everybody okay with that? So when we do PMIs, I want you to understand how to get the k plus 1 too. Okay? Copy it down. Then I want to show you one more thing. Yes, sir. Pardon me? Yeah, plenty. Plenty of lovely. We finish in 3 or half 3. 3. So the break had to be short. When I give all, or then break, I'll now come from home. I'll now come from home. Right? Copy it up and then tell me how we can write number 5, number 6. Alright, what you all got here? Right, so here what I want, right? I don't want the answer. I want to be able to write this in summation form. Right? I want to be able to write this in summation form. Think about it, right? I want to combine these two into one summation. Ask yourself what is this? And then you might be able to put them together. Might. All right, let's see. So, what you all may have recognized, right? You all may have recognized that the first three terms here is what? 2, 1, 2 by 2, 2 by 3, and now they want to add 2 by 4, right? So really and truly, we just adding on one more term. So now we'll end up with the summation of R going from 1 to 4 of 2R. These two are the same things. You all seen that? Huh? How you went to 4? Because here is 1, 2, 3, and we have 4. So you're summing from 1 to 4 of 2R. That's okay? So generally, what you say, I'm Joseph. Generally, here's what we're going to learn. What we're going to learn is that if we sum R going from 1 to K of any function, and we add it to the K plus 1 term, well, what we're going to get all the time. So if we sum R going from 1 to K plus the K plus 1 term, we are always going to get what? R going from 1 to what? 1 to K plus 1. That's okay? So it's important that we understand how to go from here to here and vice versa, right? So if I said, split this up, the way you split it up, you sum from 1 to K, and then you add the K plus 1 term separately. That's okay? Those who did PMI, you would have seen this already, right? Nobody see PMI at them? Okay, good. I like to be ahead. That's good. Today we're going to do all our PMIs. So no break. Except when you grow up with all right. So it's important that we understand the concept. That okay with us? Everybody okay with us? Nathan? You sure? So whenever you sum a whole set of values from 1 to K, and you add the K plus 1 term for that same function, when you add it all up, you're going to get the summation of R going from 1 to K plus 1. Everybody okay with that? Chloe? Sure? Okay. So now for the exciting part, kind of PMIs. Kind of proof by mathematical induction. Right, we'll start with some easy ones and then move on to something harder. Oh, sorry. Proof that walk around there. I'm asking something. Proof by mathematical induction. Proof by mathematical induction. Yeah. Right, sorry. Right, so what is PMI? Right, remember last week I showed you all something called a direct proof. Take the left hand side, right? I showed you right hand side equal and so on. Or you take a statement and break it down until it's true. Right. Today we're going to do something called proof by mathematical induction. So we have various steps to follow before we can say that I prove it. Okay? So if we have a statement, P to the n, or proposition P to the n, to prove, right, to prove by mathematical induction, here's what we do. Number one, we have to show it holds to the first value. Sometimes the first value is 1, sometimes it's not 1. But whatever the first value is, we have to show it holds. So we have to show it holds for the first value. Most of the time this is n equal to 1, right? But not all the time. So I use the word first, right? Show it holds for the first value. Once it gets you with that, you go to it. If you don't get you with that, right? Probably you choose the wrong path. All right. Next, what we're going to do, right? Because remember, we have all these values to prove, but we can't prove all the values. So we can prove the first value correct and 2 values inside it correct. If those 3 correct, then we assume all correct. Okay. So here we're going to do now. In order for us to develop like k plus 1, we're going to assume p to the k is true. Right? So we're going to assume that when I put k in the statement, it's true. Then here's the hard part. 3 is the hard part. We have to show p to the k plus 1 holds. Okay? We had to find a way to show that this random statement makes sense. Okay? Using this. And I'll show you that, right? And then if you do that, you're done. By PMI, it holds for all values, right? That symbol means for all, right? For all. All right. So if we go down to this step, show it holds for the first value, assume p to the k is true, show p to the k plus 1 holds. This is the main statement. And then by PMI, it holds for everything. So we have technically 4 steps to show. Okay. Copy that down and let's try some examples. Today we're doing all. We're doing summation type, we're doing divisibility. And I might just show you some inequalities also, although it never came before. But that's based on how you'll be even after that. Might be good. I'll be very like you great one. That's what you want. Why so fast? Are you ready? Well, who bring it up to my class? You ready? All right, let's go. So, right, here, of course, we're using for all n is a natural number, right? So the first value here we could use as 1. All right, you all ready? Right? This just means for all n, all the values here belong to natural numbers. 1, 2, 3, 4, 5, 6. First value is what? N is 1, right? All right. So let's go with step number 1. Step number 1 is to show it holds. Show it holds for, what's the first value here? 1. N is 1. So show it holds for n is 1. So all we're gonna do, take the left hand side. Left hand side is just one value, right? So n is 1, one value. 1 squared is 1. Then we go to the right hand side and we find it and we work it out. 1/6 by 1 by 1 plus 1 by 2 by 1 plus 1. So that would be 1/6 of 2 by 3 is 6. Answer is 1. That's okay?
Yes, sir.
So therefore it holds. Are you okay with that? Upside down? You okay with the first one? Right? So it holds, n is 1. Left hand side is 1, right hand side is 1. If this don't work out, Nathan, there will be some problems, right, Nathan? Right? Right? Second step. Second step. We have to assume it true for when it's k. So we write assume true for p to the k, which is p to the k is just simply p to the k means wherever n is, we place it with k. So you'll get the summation of r going from 1 to k of r squared. All here, right? We only change it n, not r, only n. All the n's now become k. 1/6 k, k plus 1, 2k plus 1. Are you okay with that? All we're doing is put k wherever we have n. Everybody with me so far?
Yes, sir.
Right. Now for the important step. Right? We have to show it holds for n equal to k plus 1. So instead of writing k, I'm putting k plus 1 everywhere. So that'll be the p to the k plus 1 statement. R going from 1, all are doing k plus 1, k plus 1, k plus 1, k plus 1. Right? And then we had to simplify it. Okay, sure. So it will be k plus 1. I put in k plus 1 here, then plus 1. I put in 2 by k plus 1, then I put in plus 1 after. So when you simplify it, you'll get 1/6 k plus 1, k plus 2. Multiply this out. 2k plus 2 plus 1, that's 2k plus 3. So, this is what we have to prove. All right? Write it down, soak it in a little bit, and then we're going to understand the real thing. We'll start as yet. We're now going to start the question. We're now going to start the question. Yeah, we started yet? We didn't start the question as yet. We are about to start it. Huh? It is underneath. Well, I do know what it's called. What is called? I got it. Why is it build up? I'm better than one to take it. Somebody knows. I have somebody first. Somebody. Right, so we did. Hopefully, we did nothing complicated as yet. Right, all we did here, well, I cannot jumble up the way I write it, so it's probably looking complicated. But all I did, instead of writing n, I write k. Instead of writing k, I write k plus 1. That's all. Anybody confused here, Emma? You okay? Anybody online confused? Right. So now we have to figure out how to prove this, how to show this equal to this. Right? Yeah. So we have to show why it is k plus 1 is equal to that. Right? Am I ready? Right? So our objective is really to prove that the summation of r going from 1 to k plus 1 of r squared is equal to this. All right? So we are going to take the left-hand side, and we have to find a way now to prove this. We have to prove somehow that that is equal to this. Okay? And all we are allowed to use is this. Right? The assumption we made. That's all we could use. All right? So when you're ready, we're going to write this next step here. Papa, you pick on somebody. Like you pick on. Right? So if you remember a little while ago, I showed you how to split up r going from 1 to k plus 1. How you do it again, Chloe? How you split up this? Check back at the last example I showed you. So summation of r going from 1 to k plus the k plus 1, 2. Everybody okay with this? It's a rule that we have to remember, right? You done? You good? All right. So you add this and this. Everybody okay with that? So we go and add this and this. Right. Quick question. Everybody okay with the first line? And yeah, right? This was showed you a while ago, right? Right. And we know what this is. Right? We know that the summation of r going from 1 to k of r squared is this. So I could take this off and write 1/6 k k plus 1, 2k plus 1. Everybody okay with that? Yeah? Tell me what is the k plus 1 term? K plus 1 in here, right? K plus 1 squared. We have to make that look like this. Okay? Everybody watch here, because here's the hard part. Right? I expect you to be able to reach up till here. Hard part is after this. You recognize this not factorized. This factorized. So we had to find a way to factorize this to make it look like that. So I'm going to give you a little help. You'll recognize that there's a 1/6 outside. Right? So what I'm going to do is put 6 on 6 here. So it means that we could factor out 1/6. How much we'll get here? If I factor out 6 and I'll get 6. Yeah? So what can I factor out again? They both have k plus 1. So I could factor out 1/6 k plus 1. What am I left with? This will cancel. I'll get k by 2k plus 1. What would I get here? 6 by k plus 1. So we get in there. This is 1/6 k plus 1. Double. It's up. Yeah. Where did trouble happen?
Yeah, but
Factorization. So I factor k plus 1. Right? And 1/6. So you're left with what? K and? Right? What you're left with here? If I take out 1/6, I'll be left with 6 and k plus 1. Yeah? What? If you have 6 over 6 and you take out, same thing. If I factor this off, I'll get up, right? Sure. Right now, outside okay. Inside now, I have 2k squared plus k plus 6k plus 6. That's okay? So I'll get 1/6 by k plus 1. Do a little thing inside here. I'll get 2k squared plus 7k plus 6. And now I can do a little factorization. If I factorize in here, I get 7, right? So that'll be 2k by k, and probably use 3 and 2. Right? No need to hurt your brain, because what? Already have this. So just this I need, right? So that's the answer there. You see that? So now the left hand side equals to right hand side. So you could just do a little box here and you're done. Okay? You're seeing that? This one is the same thing? Yeah? So you're done. The box means QED. It means proven. Right? What I was saying there. Right. So now you have to write your last line. Since it holds for n equal to 1, n equals to k, and n equals to k plus 1, then by PMI, it holds for all n belongs to natural numbers. Okay? Take it here. Copy it out. How about that? Right here. How you get a k plus 1 to set another y level. Put k plus 1 where they are. Right? Copy it down and then we do an easy one. Well, you can just look up there. That's blurry. For that blurry. No, because some of them was given, some days by some. Well, I'm not going just going straight into the now it's going. Copy down and we began to on this now. Yep, like this one good.
Yeah. Well, I'm gonna start wondering like one thing. And I remember this depending on it, you are telling something that's wrong.
Yeah. Sorry. Since it holds for n equal to 1, n equal to k, n equal to k plus 1 is the marker. Then by PMI, it holds for all n natural numbers. This symbol is for all. All right, so here's what you're gonna do for me now. Try number 2. Try number 2. This one not difficult to factorize, right? Try number 2. Summation of R equal to half by S. R, yeah, R alone. Just R. Nobody else but R. Go ahead. Go through all these steps. Let's see if you can get a full sort. But I think it's like 7 or 8 marks, right? So you just get marks up until here, like 2 or 3. You just get like 3 or 4 here, and then the last one. Okay? So go through all these steps one by one. Take your time. Take time, right? Go all these steps, see how far you can do. That's good. K plus 1 2. K plus 1 2 is always put in K plus 1 way out. Right? K plus 1 2, take off R and put the K plus 1. All the time. Wherever R is, put K plus 1 to the biggest good. Okay? And if you lost, don't worry, I'm gonna show you that's now, but see how far you could reach, right? Take a skip off that. Right. Yeah. What the information of our What is it? Right now. It's just simple. Yeah, it doesn't feel like Alright, so watch it. Let's see what you got, then we're going a little bit harder. You got through? Right, so n equal to 1. Left hand side is 1. Right hand side is a half by 1 by 1 plus 1, which is 2 by a half is 1. So therefore it holds. Now k plus, sorry, assume 2 n equal to k. So I'm going to take up n. I put k, I'm going to take up n and put k. Right? So we'll end up with something like this. So we're going to use this now later on, right? So now, how do I get k plus 1? All I have to do is where I have k, put k plus 1. Where I have k, put k plus 1. Where I have k plus 1. Don't forget the plus 1 after. So now we'll get a half k plus 1, k plus 2. That's okay? Now, this is what we have to prove. We have not proven it as yet, right? So when you reach here now, we're gonna prove that this left hand side equal to this. All right. So we're now going to write that and same statement all the time. You all recognize I'm leaving the same things, right? Okay. So the summation of R going from 1 to K plus 1 of R is the summation of R going from 1 to K plus the K plus 1 too. Where does this come from? Right here. So that'll be a half K by K plus 1. Where does K plus 1 2 come from? Put K plus 1 wherever you see an R on the left hand side here. There's only R, nothing else. So take off R and put K plus 1. Because you want to factor out a half, put 2 on 2. Everybody okay with that? Next step, factor out your half and factor out K plus 1. Right? Now you're left with what? You're left with K. The half will cancel and you'll get 2. K plus 1 will cancel. And you're done. That's it. Right? This box means that you complete the proof. Okay? It's supposed to be a square, right? And then you have to write that since it holds n equal to 1, K and K plus 1, it holds for all. You have to write this up. So you would get like 1 mark, 1 mark, 1 mark. That's 3. And you might get 4 here and 1 here. Okay? If things go bad, I mean, this won't happen to you, but if things go bad and you can't prove what you want to get, you could reach here and then write the answer and then write this. Here you'll get some marks. Okay? Let's go again. A little bit harder now. A little bit harder now, right? Online, any questions? You're okay online? Yeah? All right. That's good. I'm gonna get one from here. Right out there. We have more to do. Right? Number 3 of the R. You'll see in the back. Narayan see it? R by R plus 1. This is R by R plus 1. It's 1, 2, n plus 1, n plus 2. Oh yeah, try that there. Huh?
Yes.
Well, then if you get method QED, right? You follow it. How about you? Nice. Right, so when R is 1 by 1 plus 1, that is 2. Here is 1/3 by 1 by 1 plus 1 by 1 plus 2. 2 by 3 is 6, 6 by 1/3 is. So it holds, right? R equal to K. So that'll be, sorry, R going from 1 to K. So taking off K, taking off, and replacing with K, sorry. Next here, I'm taking off K and I'm putting K plus 1 now. So really and truly, this is what I have to prove. Right? I have to prove 1/3 K plus 1, K plus 2, K plus 3. Right? So now the summation of R going from 1 to K plus 1, I have to prove this, right? So usual thing, R going from 1 to K plus the K plus 1, 2. That's okay? Usual thing, this comes from here. So that'll be 1/3 K by K plus 1 by K plus 2. How do I get the K plus 1 term? Well, just put K plus 1 in here. I'll get K plus 1, K plus 1 plus 1 is K plus 2. All right? That's all. Right? What's that? K plus 1 term, just put K. So you know what you should do? Write it in your own words. Right? To get the K plus 1 term, put K plus 1 here and K plus 1 here. Yeah? Sit down. The office. Ask me the office. Oh, we lost it. But have one in the office. Right? Put K plus 1 here and here. Now, what we're going to factor out? We're going to factor out 1/3 K plus 1 and K plus 2. What we left with here? K. What we left with here? 3. That's it. Okay? Let's go harder now. No. Oh yeah. Almost there. Right, we got a hard one. Yeah. What hard one? Then you put that mark to us. Right. What the industry rules again? I'll look at handle that man. I'll handle. Industry rules and the power. I can take off this. But yeah. How I get this? K plus 1 in here is what? K plus 1. K plus 1 plus 1. Right? Right, we do go too far, right? Three to answer. 150, isn't it? How far would you? Sure, if you hurry up, so I can order it and then I'll pick it up. Or you can order it, like, come here, or 15 minutes. Right, between visits. One in March, yeah, I give her like a 5. Right, try this one here, please. Yeah. All right, what you see here? Problem with this one is number one, they didn't give us any summation signs. We had to put it into a summation form. And here we have indices 2 to the n minus 1. Here's 2 to the n. Right? This is what? This is 2 to the n minus 1, not 2 to the n minus 1.
So we can differentiate.
So write it properly. Yeah, you can differentiate it. You can do anything. Right? Question. Before you start it, how do I write this other summation? How do I write this other summation? The summation from what to what? Because I want to make sure you can do it the same way, right? How can I write this other summation? Right? R going from 1 to what? R going from 1 to n. And what's the function? 2 to the power. Think about it. 2 to R is 1, 2 to something, right? So the function will be 2 to the power of R. Check and make sure. 2 to the 1, then it's 2, then 3, and then n. Okay? So this is what you're proving. Just be careful. You have to use the indice rule. Same base here, add the powers and so on, right? Remember that? What does this mean again? In indices. It means what? 2 by k, sorry, 2 to the k multiplied by. Remember those small things, right? You might need it somewhere. Go ahead. So again, if you see it like this, but you used to working with a summation, then take it from here to here. Okay? After this one, I'll give you a small break. And then we have more, maybe some harder ones, and then with the divisibility, which is easier. I have that fast. Online, if it gets you, just send QED, right? Nathan, you done? Nathan. Let me get it. How much is X plus that? Right. What is K plus B? How much is the 230K plus 230? 230K, right? 59, right? If you add 230K to 230K, you will get 2 of them, right? Let's keep that in mind. Why is it have to? You can put it in this detail earlier. Right. Now let's point out something here that seeing, right? What you see? Just glance here for a minute, right? Because I don't want all the thing invent all the own maths, right? When you do your PhD and research and thing, or they could do that then. But for now, let me use what people invent already. So what you see? 230K plus 1 is what? 230K multiplied by 231. That's okay? If you want to write it, you can write it like this. Are you okay with that? Don't multiply the 2 and 2. 2 by 2 is not 4 in this case. Okay? You can't do it because of indices. Right? You all may not remember, but mass could also be written like this. You must do the exponent first before you multiply. So don't multiply 2 by 2. That's wrong. Okay? All you can do is leave it like that. And the question I asked earlier was this. What is 2 to the k plus 2 to the k? 2 to the k plus 2 to the k is 2 of them. Right? Which could also be written like this. And you have your answer. You might need this somewhere. Oh yeah. I'm giving you 2 minutes again before you jump in. Anybody have it? Think they have it? Somebody else? You can find right here. That's you're not seeing something for All right, let's see. Everybody watch here. We have more to get, don't worry. Right? Some of you are getting trouble on the part where you have to bring the indices together, right? So let's see how we handle that. So left hand side is 2 to the 1, which is 2. Right hand side is 2 by 2 to the 1 minus 1. 1 by 2 is, therefore it holds. Right? P to the K statement. P to the K statement is the summation of R going from 1 to K of 2R is 2 by 2K minus 1. Everybody okay there, right? Then the P to the K plus 1 statement is what? The summation of R going from 1 to K plus 1 of 2R is equal to 2. Change this and write K plus 1. So we had to prove this. That's all. You okay with that? Now let's focus on starting here now. So let's start right there. R going from 1 to K plus 1 of 2 to the R is the summation of R going from 1 to K of 2 to the R plus K plus 1, 2. What this is? Right here. 2 by 2 to the K minus 1. What's the K plus 1 term? Take off R and put K plus 1. That's okay? I showed you a little while ago. If you want, you could expand this out. You have different options, right? You could expand it out. right? You could write 2 by 2 to the k minus 2, and you can rewrite this as what? What you can do here? 2 to the 1 by 2 to the k. So you can start with that if you want. It's up to you. All right? When you reach here now, you'll recognize all of them have 2. So can I factor out 2? Again, what's your answer? You want to get something like that, right? So can I factor out 2? Yeah. So I'll get 2 to the k minus 1 plus 2 to the k. What's the usual thing in maths? Bring a like terms together. 2 to the k plus 2 to the k minus 1. 2 to the k plus 2 to the k is how much? If I add up 2 to the k's, I'll get 2 to the k. That's okay? X plus x is 2x. You'll see enough? Yeah? Sure? Now this is same base. I can add the powers. Is that the answer? Yes, it is. If you wanted, you could have factorized some right here. You could factor out 2 from right here and you'll get this line. You okay with that? So just to get used to working with the indices, right? Power. Tanga. Power. Which lines? Follow what I did here? The last 2. So after I did here, I brought them together. If I have 2 are the same thing when I add it out, get 2, right? So when I add this plus this, I get this. Same base, so I add the powers. 1 and k plus 1. Okay, nice. Take a 5 minutes, then we go again. Right, we start back at actually I'll give you a little. Nah, not yet. Starting back at 2:15. You'll get 9. 9 minutes. 2:15 and starting back. And no break until later. I mean now. You know what I mean?
Until later.
You know what I mean? Be confused, I know which part you get in trouble.
Yeah, you got to.
My quote. That's a different place. When I look at the idea. And everybody's what it will be out there for you. Just fine, right? Just see fine.
See the guy with the house.
Anything that leaks, yeah, you can take it.
So that they're on this philosophy.
But I have a until the time comes, I'll take this. But it won't be that simple. But it will simplify it so that we can take it. But if
So all up to your size.
the same thing similar. those calculations don't come by guarantee. But like trading, I think over the kind of way.
Yes,
It should. Like things like that. You're not designed to handle these type of things. But you'll have to look at what the idea that behind the scenes. So that look at the we got this standard in it.
Yes, taking sliding if it would be.
Something along that. That's what AI whatever. Alright, so next one, divisibility. I mean, before I give you divisibility, I'm gonna give you one hard one now, please. I want a hard one or just one? Let's go again now. After this one, I will change it and I'll give you divisibility. But divisibility really, right? I'll give you two easy and a hard one. Guys, please. Hurry up. Start that part. Sit down. Start that quick. Just pull it left, man. Right, let's go. Try this here. Pardon me? If you want, yeah. If you want, it's up to you. But yes, you can do that if you want. Go ahead, have one. Right, after this, we'll switch to the visibility, right? Right, on the LMS, you all will see more questions, some hard ones, right? I say this, huh? So I guess you're ready? And now hold it. Yeah, hold it. Yeah, so again, R is 1. 1 over 2. That's a half, right?
Yeah.
And here is what? 1 minus a half. This is a half. Right? So it should hold. Because of the time, I mean, Take your time dealing with the indices, right? Right, and then we do some divisibility. What's that one? Sorry, but I can do it. How are you breaking this down? Most of you all may have reached right here and wonder what to do. Right? This is the same as what? Take it step by step. Can you break this down?
Yes, sir.
What else? Right? So if I separate it, can I write it like that?
Yes.
Like a half, right? Think about it like that. Might help you. Right, so let's do two more there and then we'll get it kind of thing out of the way because although we have no class next, we get a class, we talking about that for you. Sure, like, we had it here, like, so.
You like to take right? Yes, it's too much.
Alright, let's see where you reach. Yeah, the one line to write it going. Just you. That are right. One of what. Let us see what you got. And anybody get it? You'll be surprised how easy it is, huh? It just not seeing one little thing. Right? If you're not, here what you can do, right? Instead of writing 1 over 2 to the k, let 1 over 2 to the k be x. So get rid of that. So and write x instead. And you'll see what will happen. You have the answer. Instead of writing 1 over 2 to the k, we write x. So everywhere you have that, put x. When you start to simplify, watch what will happen. I will do it. And you'll see you'll get the answer. Right? So left hand side, when n is 1, 1 over 2 to the 1 is 1 over 2. Right hand side, 1 minus 1 over 2, which is a half. Right? P to the k, that's the summation of r going from 1 to the k of 2 to the r, 1 minus 1 over 2 to the k. Right? Ideally, I should be writing this, huh? K is an element of n, right? P to the k plus 1, summation of r going from 1 to k plus 1 of 1 over 2 to the r is equal to 1 minus 1 over. So we are trying to prove this here. We are trying to prove that. So we're going to take the left hand side now. Summation of r going from 1 to k plus 1. So I'm going to put this here. This is the same as the summation of r going from 1 to k of 1 on 2 to the r plus k plus 1 term. I'm not writing that. All right, then k plus 1 2. This here we know it already. Right here. 1 minus 1 on 2 to the k plus 1 term is this. 1 over 2 to the k plus 1. Right, it should reach there. And I showed you how to break this up a little. That'll be 1 minus 1 on 2 to the k. We could break this up and say 1 over 2 by 1 over 2 to the k. Remember I showed you that? Right? This is 2 to the 1. 1 plus k is k plus 1. Okay? I just separated as a product. You okay with that? Now, this confusing a lot of you all. So here what I'm going to do. I am going to write let x equal to 1 on 2 to the k. That's okay? Watch what's going to happen here. I am going to get 1 minus x plus a half x. That's okay? What is minus 1 plus a half? What is minus 1 plus a half? Minus a half, right? That's okay? Right? A half plus minus 1 is minus a half. Everybody okay with that? The answer right here, you know. Watch this. I'm going to substitute the graph now. X is really what? 1 on 2 to the k. Correct? And I'll already show you what this is. This is really what? 1 minus 1 on 2 to the 1 by 2 to the k. 1 minus 1 over 2 to the k plus. That's it? QED. Right? So you had the answer. You all had the answer. And right there, but you're not seeing it because you're not identifying this as the same thing, right? So my advice in cases like that, make a substitution. Nothing wrong with that. Make a substitution and work it out. That's okay? All right, head up the visibility now. Same PMI. Last one was summation, now is divisibility. Anybody confused? Right? The objective is to make it look simpler. If an X making it look simpler for you, put in an X. Okay? Next one is divisibility. Same 4 steps. And it's much easier. Right? So let me see if we can do a easy and a hard. And I'll let a guy come. Right. On the LMS, send the link for you to rejoin, and he sent all the username and passwords. Right? So in a little while, I want you to go find your username, password, login. You have to change your password because the whole world know it now. Right? So you'll have to change your password at some point in time and store it somewhere on your phone. Okay? I'm going to be sending you notices there, work there, small things there. Okay? I want you to use it. I can see when you use it. I can see how long you use it for. Right? I need to monitor you, especially online. Could always fun.
Look, I one chat. I think you should call on them.
No, just one person, all this fun. And let's send something. So we're taking a look at divisibility. How do we prove that something is divisible? Também matama sketch back. No? Absolutely. Nobody writing, right? All right, let's do an easy one. I mean, let's do one first, and then you will judge if it's easy or hard. Head up the visibility, right? They're on the front side. All right, ready? So you want to prove that 6 to the n minus 1 is divisible by 5. That's okay? Watch it here. Ready, watch. A few steps and you're done. So when n is 1, what will happen? You'll get 6 to the 1 minus 1 is 5, which is what? Right? Therefore, divisible by 5. You okay with that? Next step. P to the k is what? P to the k is 6 to the k minus 1 is divisible by 5. How do I write that? To write it, what I could do is this. I can write 5 by some random letter. That's okay? That's all. From this now, here what I could say. 6 to the k is 5a plus 1. I just move it across. That's okay? So I'm going to use this somewhere in my proof. Now, p to the k plus 1. P to the k plus 1 is 6 to the k plus 1 minus 1 is 5 by some letter. Let's call it b. Right? So I have to show that this is 5 by some random letter. But okay with that? So I'm going to take this left hand side now and prove this, right? Right? So left hand side. After work with 6 to the k plus 1 minus 1. How am I going to randomly show that this is divisible by 5? First step, I'm going to expand it a little. 6 by 6 to the k minus 1. Are you okay with that? Yeah? Stand it. So now, since we know that 6 to the k is equal to what? 5a plus 1. Since we know that 6 to the k is 5a plus 1, then I can make a substitution. I'll get 6 by, replace this with this. Right? Are you okay with that? So I replace 6 to the k with 5a plus 1. Multiply this out and you'll get 30a plus 6 minus 1, 30a plus 5. Can I now factor out 5? So I get 5 by 6a plus 1. Once you factor out 5, it's divisible, right? So you have to say is of the form 5 by whatever this is, which is b. Therefore, and then right here, since it holds for everything, right? Does it? Right? Once you can factor out the 5, it's divisible by 5. Okay? That's it. Right? This is the next time. I'm gonna give you our next one. Any questions? Right? Earlier, here, you can do whatever you want, huh? You can make A the subject, you can make 1 the subject, it's up to you. It don't matter. Different books do different things. Right? So I made 6 to the k the subject and make a substitution. You can make 1 the subject and make a substitution. It don't matter. Hurry up. No, what happened? Something. I can order this. Ami online here, Ami paying attention. Important now. Whatever CS said that voice start on the I don't know what la finish them up. Let's just give you one. I sit down here, relax. Right, can you have them? Let's see, we have from my head, seven, that is for Guys, when I finish, this one here, 7 to the n minus 1 divisible by 6. It was basic, right? I give you 2 minutes to put out. Yeah. 7 to the n minus 1. And I'm at there already. Right, Keisha, I just Keisha. Keisha, what is it in your marks? Yes, sir. I'm at there already, yes, I'm at joining again. I'm at there. Amen. Yeah, all right. Somebody trying to join with your same name. Next cell. Ahmed. I see Ahmed here.
How many years? Our artist.
Oh, yeah, Ahmed. Okay, right. Oh, yeah, that's fast.
You take that one.
Seven to the n minus one, right? Now, you finish already? Well done. Yeah, well, try and finish it now. Well done. Please, can you have it correct? The last line as a mark, right? So just work it out and be happy. No, the same 73 and minus one. And then you get next one. Right. This thing come for a year or two, yeah, man. Right, so should be almost done. Right, so left hand side, 7 to the k minus 1. So that'll be 7 by 7 to the k. But as I showed you there, 7 to the k is already 6a plus 1. Right, so now I could replace it and I could write 6a plus 1 here, 7 on the outside. Right, multiply it out, you'll get 42a plus 7 minus 1. 42a plus 6, you can factor out 6. You'll get 7a plus 1 is of the form 6. That's it. All right, let's try one slightly harder. Double that up. Go.
All right.
Online or against you? What you send anything? Last one. Again, this one from.
So wait a minute. You check the part of the.
Take your time with this one, right? This one a little bit longer because you have to. How you expand k plus 1 cube? K plus 1 by k plus 1 by k plus 1, right? This one a little bit longer. This is the last one, right? If you end up with a 0, that's okay, yeah? Technically, it's still divisible by 3, right? Right, let me just check out this. One hard, I take the time. Right, while you're waiting, I'm going to give up. Try the level the element now, right? One harder. Biggest view that's okay. Just says theory visible by 3. Right, while you're waiting, right? I want you to log on. Anyway, I'll give you 2 minutes to do that just now, right? I want you to log on and open up something like a U business, right? Watch a video for 10 seconds to talk. So I can see a unique system. I can see that you log on and it's good job. Check on the group. Check on the WhatsApp. The same knowledge. Who has now the WhatsApp group? Right? If you get invalid, you just tell them and you'll fix it. Right? Crash course empty.
Yeah.
How they in crash course or in to the yes? Probably that's why it's empty.
Yeah.
Because you're in dry. I'll give you all last year one. Right, n equal to 1. You got 1 cubed minus 10 by 1 plus 9. So you'll get 0. We can consider that to be divisible, right? Then p to the k, that'll be k cubed minus 10k plus 9 is equal to 3e. If you want, you can make 9 the subject, you can make k cubed, you can make minus 10. It's up to you. Right? It don't matter which one you make the subject, it will still work out in the end. But my advice is just leave it like that for now. Then we will see what to do from. Right? P to the k is k plus 1 cubed minus 10 by k plus 1 plus 9. That will be divisible by 3p. So we're starting with the left hand side. That will be k plus 1 cubed minus 10 to the k plus 1 plus 9. So we have some expanding to do. Wait, is it 9? What am I the wrong thing? Anyway, you hope for the best. Right? Then we expand this out. When you're expanding this out, you expand k plus 1, then multiply by k plus 1. There's a shortcut, but I won't show you that. 10 to the k minus 10 plus 9. Expand these two, you'll get k squared plus 2k plus 1. And multiply it by k plus 1. Here, you'll get minus 10k minus 1. Right? Expand this out now. K cubed plus 2k squared plus k. Multiply everything by 1. K by all of this is all of this. 1 by k squared by 2k by 2k plus 1 minus 10k minus 1. Okay? K by k is k cubed, k by this is this, k by this is this, 1 by this is this, 1 by this is this, 1 by this is. Right? So we're not going so bad as yet. What's the next? What's the next step? There's only 1 k cubed. 2k squared plus 1k squared is 3k squared. K plus 2k is what? And then these ones will cancel.
So after minus 10k.
Yeah, I'll leave it for now. I'll show you why that's not. Minus 10k and the ones will cancel, right? Right. So I want to show you something here. There's a reason why I left 10k. Because I recognize that I have k cubed minus 10k here. You're seeing that?
Yeah.
So can I make k cubed minus 10k the subject of the formula? Yeah, move across the 9. So now I could take off k cube minus 10k. You recognize I have 3 and 3 here already, right? That's good to go. So if I take this off now, if I say since 3 to the a minus 9 is k cube minus 10k. So if I take this out and write this, I'll get 3a minus 9 plus 3k squared plus 3k. What you will recognize is that they all are divisible by 3. So I could factor out 3 and I'll get a minus 3 plus k squared plus. All right. Again, you didn't have to do that. You could have just make k cubed the subject and substitute. You'll get the same answer. Okay? I know it's a lot. You all survived. That wasn't bad. 2.5 hours, we could keep this right through. And that, no, I'm joking, because I would have had it. Normally I would.
I don't see it, I think